Today we're going to talk about finding zeros and working with quadratics. And so this is number 15. So we're going to look at a couple definitions real quick. So quadratic roots, that's the first term we need to look at. Quadratic roots are just solutions to a quadratic equation. And I always write too big for the box, right? Oh, no S. So it's a solution to a quadratic equation. Now, the generic quadratic looks like this: ax squared plus bx plus c, where a is a number, b is a number, and c is a number. Now, a quadratic equation, we set it equal to 0, and then we solve for x. And there are actually 3 ways that we can solve for our x with the quadratic. The first way we can do it is the way that we're going to show you, graphing. The second way you can do it is by factoring. And the third way to do it is to use something called the quadratic formula, which we will show you later on this week sometime. So just to give you an example, I'm going to write above here. An example of a quadratic would be something like this: x squared plus 5x plus 6. Okay. Now, right now there's not a number in front of x, but we know it's 1. They just don't write it. So a would be 1, b is 5, and c would be 6. But really what you're looking for to be a quadratic is the squared, the x squared, or whatever variable squared. Usually they'll use x, but it can be any variable. Now, they call the solutions, or the zeros, or the roots, different names. So we already know they say find the roots. They will also say find the zeros. Okay. And sometimes they'll just say find the solutions. So what most people, if they struggle with this, is because they're not familiar with all the ways they can ask you the same question. And we have some examples of those in a couple minutes. All right, so with these quadratics, with these equations or graphs that we're going to look at, you're going to see that they are a parabola. Okay, and a parabola is just a U shape. When you graph it, it is a U shape. And so what you're going to see with your parabolas is one of 3 things happen. You can have 2 solutions, you can have 1 solution, or you can have no solution. And it's going to depend on the graph. So let's say you graph the U shape and you're going to have 2 solutions. It's going to look something like this. Okay, and it can be anywhere on your graph. Okay, this is just an example. So the reason this parabola, that's what the U shape is, the reason that this quadratic has 2 solutions is because if you look, this is your x-axis. Your parabola intersects your x-axis in 2 places. Okay. Since your parabola intersects your x-axis in 2 places, it would have 2 answers. Now, if you have a parabola that only intersects your x-axis in 1 place, for example, a parabola like this, okay, and your parabola can kind of go any direction. It can open up, it can open down, okay, it can be anywhere on the graph. But in this case, and I'm going to zoom in a little, there's only 1 solution because your parabola intersects your x-axis right there in 1 place. Happens to be the origin here. Remember, this is your x-axis. But that would only have 1 solution. The last thing that you will see today with some of these is that when you graph, or when you look at a graph, your parabola might be right here. Okay, and if you look at that parabola, it is not ever going to intersect your x-axis. It's going to continue to go up on both sides, but it will never come past, it's called the vertex of the parabola. And so this would have no solution because it does not intersect or touch your x-axis. So there are lots of ways they can ask you this. So here are some of the ways. The first way, they could, of course, say, what are the roots? Okay, so we already looked at that at the top. They also could say, find the zeros. They also can say, find the solution or solutions. It just depends if it has one or more. So in parentheses, we'll put S. They can also say, find the solution set. Still means the same thing. Now, really, if you're paying attention, if a graph crosses the x-axis, that is called the x-intercept. So they could actually even just say that. But all of these keywords mean you're looking for where your graph intersects your x-axis. That's all you're looking for. Okay, so strongly recommend that you actually memorize what all of these mean. Excuse me. Roots, zeros, solutions, solution set, or x-intercept just means where does your graph intersect the x-axis? Because there you're going to see in a couple minutes, they ask it every way possible. Lost my dots there. Okay, so you want to be prepared so that you don't get to a question and not understand what they're asking you. So just some examples of the types of questions they can ask you. What are the solutions? What is the solution set? What are the zeros? Identify the root or roots. What is the x-intercept? All of these questions mean the exact same thing. Okay, and that's why we try to get you guys to memorize roots, zeros, solution set, x-intercept mean all the same thing. Now, there are two things you got to be careful of. Okay, and it's this right here. Okay, these two things mean two very different things. The first set is a parentheses. Okay, and when you put an answer in parentheses, remember that represents an ordered pair. So I would write that down. When you put something in this type of notation, and some people try to say they're brackets. Those are not brackets. If you look, they have a little curve in the middle there. That is actually what we call set notation. Okay, and that means something totally different from an ordered pair. And I'll explain it in a minute. So just label those two things. It's a small attention to detail, but you do have to pay attention to that. Otherwise, you're going to get confused. All right, so we're going to look at two problems. Okay. The problem on the left with the U shape is the new stuff that we're talking about today. There's your parabola. The problem on the left is what we talked about a couple weeks ago when we talked about systems of equations, okay, where you have two lines, you graph them. If they have a solution, it's where your two lines intersect. Because remember, sometimes they will intersect, sometimes they will run parallel, and sometimes when you graph them, they'll end up being the exact same line, and they all have their own different answers. All right, so let's look at the graph on the left. Given the following graph of h of x, again, do not let the terminology throw you off. Remember, this just represents function notation. That just tells you that for every x, there is a very specific only one y value to make it a function. Don't let that throw you off. As soon as you see the U shape, you should know that you're dealing with a quadratic. Okay, it's a quadratic equation, which means within the equation part, you will find an x to the second power. Okay. Now, right now, we don't know if it's 2x squared or 3x squared. We don't need to know that. We just need to know that, oh, it's U-shaped, makes it quadratic, makes it have an x squared. And notice what they're asking you here. What are the zeros? So again, this is one of those key words. Zeros just mean x-intercept. So all you have to do is come up to your graph. Where does it cross your x-intercept? This is your x-intercept. They always should have it labeled. And then you just have to look on your graph. So the zeros are where it crosses your x-axis. So this actually has two solutions. Okay, and then you would write it. X equals, and that would be -2. And then you say and +4. So this particular equation would have two different solutions, -2 and 4. Now, what throws some people off is sometimes they don't write it out like that, okay? Sometimes they'll write it with the set notation. So set notation, again, I'm not an artist. Do the best that you can. Oh, that's awful. Let me try again. Okay, you don't want it to look like parentheses. Okay, just do your best. That's not the greatest. But the way they would write this was set notation has all of the answers listed in a row. Okay, so set notation, they would put, okay, I found x is -2. Okay, and it's also 4. But what throws people off is you put a comma instead of the word and. Okay, and then they think, oh, that's an ordered pair, so that means I go left 2, up 4. Okay, that is not what this says. This is set notation. Okay, and what set notation does is just give you a list of the answers. Okay, so instead of writing out x equals -2 and 4, you could also write it as the set of -2, and you would say and 4. Okay, it's not an ordered pair. Okay, if you feel like you need to write that. And again, the only way you can tell that is by the marking. This is not an ordered pair. Okay, it's set notation. Okay. Now, from the other week, what we did was systems of equations. And systems of equations have one solution, no solutions, or infinitely many. If your two lines intersect, then you have one solution. So notice the question, what is the solution? Now with linear equations, okay, equations that give you lines, clearly I have two lines, so this is two linear equations. With linear equations, okay, you do put your answer as an ordered pair. Because linear equations, they would only have an x, not an x squared. Be like something like y equals 4x plus 5 or y equals 2x minus 6. But linear equations, when you write the solution, you write it as an ordered pair. And so this, where do they intersect? You would say right 3 down 2. Okay, so please make sure you guys know the difference between the two. Because they could have over here, instead of said what are the zeros, they could have very easily said what are the solutions. Okay, they could have said, what are the roots? Okay, they could have said, what is the solution set? Okay, all of that means, where does it cross your x-axis? That is not the same when you're dealing with lines. When they say solution, okay, they mean, where do the two lines intersect? So just pay attention to that. All right, so let's look at some examples. Number 1 and 2, you got to fix a few things. A couple typos. So number 1, which apparently is a graph add of a quadratic function that has no real roots. Okay, and they put no real, when you get to Algebra 2, you'll see you'll start talking about imaginary and complex numbers. But what you really want to focus on, your keyword here, again, always be looking for keywords, is roots. As soon as you see that word, okay, what should pop into your head is x-intercepts. So then you just got to start and look at your graphs. So if I look at this first graph, okay, again, this is just function notation. It's just telling you that this is a function. For each x, it has its own y. So there's an x-intercept, there's an x-intercept. This one would have 2 solutions. Okay, so that is not what we're looking for. We go to B, okay, it's already marked in green, but this is your x-intercept. Again, it happens to be at your origin. So this would have 1 solution. Again, not what we're looking for. We're looking for none. So then we go to C. There's an x-intercept. There's an x-intercept. This has 2. Okay, and I'm saying SOL apostrophe NS. That's just my abbreviation of solutions. Probably just one that I made up. And last but not least, I look at D. Okay, and if you notice, your x-axis is way down here. That graph is never going to intersect it. So this is not going to have any roots. And again, they could have said no solution, no real zeros, no real roots. That's what those words are, all interchangeable. All right, number 2, we got to make, again, another small correction. Which graph appears to have zeros at -3 and 2? So let's change -3. Otherwise, you can't answer the question. Let's change that to -2. Okay, but again, what you're looking for are keywords. 0 is a keyword. X-intercept. Okay, so let's look at A. It's linear. Okay, that's a line, so it would be a linear equation. That would just have an x value, not an x squared. It's not a quadratic. And does it have an x-intercept? Absolutely. It crosses your x-axis right here. Okay, so your x-intercept here would be 2. And remember, if you write it as an ordered pair, it's 2 and then your y is always 0, which again is why they call them zeros, because your y value is always 0. So we do have the 2 right here, but they want -2 and 2. So this is not going to work because this only has one x-intercept. If we look at B, that is also actually called a cubic graph. And again, Algebra 2, when you get there, they'll talk more about that. Does it have an x-intercept? Sure. X-intercept means it crosses the x-axis right there. Again, that's actually 2, 0 again. So again, for us, we're just looking at the first number. Y should always be 0. So is that one of the zeros they're looking for? Yes. Okay. But does it cross the x-axis at -2? That would be a no. So that one only has one solution, or 1, 0. So let's look at C. And so I look here, -2, 2. And again, if I wanted to write them as an ordered pair, I could put -2, 0, 2 on the graph. But this does have 2 solutions. Okay, the way we'd write it with the quadratic is x equals -2 and 2. Okay, you could also use your set notation. Okay, -2. What's my other answer? 2. But that would be C. Okay. It has zeros, also known as x-intercepts, at -2 and 2. All right, let's look at number 3. What is the solution set for the following quadratic equation? So they're telling you it's quadratic, but you should have known that just by looking at it because you see the x squared. But again, start focusing in on keywords, solution set. Okay. Once again, that means x-intercepts. Now, you could do this by factoring, which I'm going to kind of help you set up just so you can see it happening. We're going to do it by graphing. You also could use the quadratic formula, but again, we'll show you that later. All right, so if you were going to do this by factoring, just so you could see it happen, you would slide divide bottoms up. So 2 times negative 2 would give us negative 4. So you set up your x puzzle. So you're looking for two numbers that multiply to give you negative 4 that add up to negative 3. So we slide. So we need two numbers that add up to negative 4. Sorry, two numbers that multiply to give us negative 4 and add up to give us negative 3. And this is where you'd use Desmos, y equals negative 4 divided by x, if you are not good with factors. But remember, we set two parentheses up. First piece is x. Okay, so hopefully everybody was able to come up with, oh, well, that would be negative 4 times 1 gives me negative 4. Negative 4 plus 1 gives me negative 3. So then remember, once you have those, you just drop them in. Negative 4 is minus 4. Positive 1 is plus 1. So slide. Now we have to divide because we slid. We slid this over here by multiplying. So what did we multiply by? We multiplied by this 2. So we divide by 2. My bad, putting that in the wrong place. Hold on. Try that again. Divide by 2. And I apologize. This is like the 4th time that I've recorded this video. So here's hoping, fingers crossed, that it actually works, because it has not worked. Which is why there has been a delay, which I am sorry for. All right, so slide, divide. Now, reduce. Remember, if you can reduce. So if I look, 4 divided by 2, okay, type in Desmos if you can't do it. It's just whole number 2. 1 divided by 2, okay, that's not going to reduce. 1/2 is going to stay 1/2. So we just drop that down. Okay, so slide, divide, bottoms up. That just means if you have a fraction still in your parentheses, then you're going to take it and kick the bottom number in front. So the x minus 2 is good to go. Okay, but that 2 down here is going to kick up, bottoms up, and so this becomes 2x plus 1. So now we have factored. We have factored the 2x squared minus 3x minus 2. To solve this by factoring, they told you it was equal to 0, or you would set it equal to 0. And then you just take the first part without the parentheses. So you'd write x minus 2. What's it equal to? 0. And then you would solve that. So plus 2 plus 2. So x is 2. So that is one of your answers. Then you do the same thing for this, whatever's in the other parentheses. So we got 2x plus 1. Set it equal to 0. Now solve this. Subtract 1, subtract 1. I get 2x equals 1. Sorry, negative 1. Divide by 2. Okay, so my other solution is negative 1/2. So if you look over here, okay, they've written it in set notation. Okay, if we wrote this out in hand, this would say x equals 1/2 and, or you could write the word and, 2. That's what the set notation is telling you. So is that what we got? No, we got negative 1/2 and 2. So it's half right. Okay, again, this is attention to detail. So it would be C. Yeah, that was factoring. Not the way that most people do it, simply because it's a little more time consuming, right? That took a little bit longer. So what you can do is you can type it directly into Desmos. Now, if you're going to type it into Desmos and use the graph, the only thing you want to type into Desmos on all of these is that. Don't type in any equals, because sometimes it'll say equals 0. Sometimes it'll say y equals 2x squared minus 3x minus 2. Sometimes it'll say f of x equals 2x squared minus 3x minus 2. Don't put any equals in. Just type in that expression. So you're going to pop over to Desmos, and you guys know I don't split screen. And you're going to type in 2x squared minus 3x minus 2. And it'll graph. If your graph doesn't look like that, hit your home button. Tap, tap where it crosses your x-axis. So everybody can clearly see negative 0.5, positive 2. Okay, now they have it as a decimal. If you're not good with decimals and converting them, take the 0.5, negative 0.5, hit your circle, negative 1/2, problem solved if you're not a decimal person. So you would be looking for, and what I tell people, if they're going to graph, okay, you're going to bypass all of the factoring because that's a bit more work. Then I say, once you graph it and get your answers, come over here off to the side. And I took up a lot of room, so I'm going to put it over. Oh, we want that. That's what you type in. Put it over here. We got x is equal to 2 and negative 1/2. I would write that somewhere. So as I scan through my answers, I make sure I pick the right one. Okay. Test taking skills, multiple choice skills, whatever you want to call it. Working smarter, not harder. All right, so number 4. Number 4, what you are going to do is you are going to pause the video and you're going to try to answer this yourself. Which function has exactly 1 0? So again, it's nice that they're telling us it's a function. Doesn't really mean anything or impact anything. Keyword is 0. Okay, as soon as I see that word, x-intercept should pop into my head. Okay, and if you need to, write it down. It needs to have only 1. So, like I said before, do not type anything equals. So when you go to Desmos, you're only typing the expressions. That's the only thing you're typing. Do not start typing in the equals. Sometimes you can, sometimes it messes up your graph. So rather than you have to think about why you can, when you can and when you can't, just don't ever do it. That solves that issue. So pause the video, type those into Desmos, see which one only has 1 0. 1 x-intercept. All right, so hopefully you paused and typed them in, but what you should have found is A is the only one. Okay, it crosses at -4, I believe, is your x-intercept. When you type in, and don't be one and done, check them all. Type in x squared minus 16, you'll find there are 2 solutions. Okay, same thing with C and D. Your graph actually intersects your x-axis in 2 places. All right, number 5. Identify all functions that have a 0 of -2. So again, it's nice that they're talking about functions. We see the squareds. We know they're quadratics. We know when we graph, we should get a U shape. What we're zeroing in on, or what we're focusing on, is that keyword right there. As soon as they say that, it's an x-intercept. So they want to know which one has, which of these, and there's 6, has an x-intercept of -2. Which graph crosses at -2? Now, this is a little time consuming, a little tedious because you have to check all 6 because it said identify all. So don't just get one answer and keep moving. Okay, this is kind of one of those do-it-yourselfer questions. Again, when you type it in, no equals, just type in x squared minus 5x minus 14. And what I do recommend people do is when you type that in, come back and write down the 2 answers or whatever answers you got. So what I would do and what we recommend people do is type it into Desmos. I got -2, +7 as where they cross the x-axis. come back over here and actually somewhere in the box, and they're not the biggest boxes, but write -2 and 7. Okay, write them in. So, we know it has a 0 of -2. So this is one of my answers. So what you want to do is type in the rest, type in the other 5. I'm so sorry, I got something caught in my throat. Type in the other 5 and see which ones have zeros of -2. So go ahead and do that. Pause the video, type them in, and then come back and check. Make sure you're pausing. All right, so hopefully everybody checked. Okay. Hopefully everybody found that the next one that worked was this. Still had 2 answers, but one of them was -2. And this. Same thing, had 2 answers. One was a decimal, but the other was -2. All right, so you guys try number 6. Identify one root. So they actually only want one answer. You might get 2. It's definitely a quadratic. You see the squared. You know you're going to get a U shape. Again, do not, they're telling you it's a function by showing you the f of x equals. Don't type that in. So pause, type it in, come back, write your answer down, and then come back here, unpause, and check. So hopefully everybody paused and typed it in. You actually get 2 answers here when you type it into Desmos. You end up with x is equal to 3 or, not or, sorry, 3 and -7. Now, since they only wanted 1, you only needed to have put 1. Okay, so you could have either written 3 or you could have written -7. All right, 2 more, and then I'm going to pause the video and let you guys take a break, and then you can come back and watch the other couple that we have left. Which of the following is a solution of x squared plus 3x minus 4 equals 0? Again, keyword. Tells you what to do right there. That's why memorize that list, those 5. So notice they're only giving you 1. It's a quadratic, so it might have 2. Type it into Desmos. No equals. X squared plus 3x minus 4. Okay, there they are. Okay, so my solutions are -4 and +1. That's where it crosses the x-axis. So again, strongly recommend, come over here or on your paper and write -4 and +1. Then come over and find your answer. Okay, these are not hard questions, but it's easy if you make a careless mistake. And if you have it written down, you're less likely to make a mistake. All right, last one, and then we pause, and then you can come back and watch the other video. It's not long, like 12 minutes, I think, to finish it up. All right, so identify the graph that has a 0 of -4. So again, key word. If you know what this means, this is easy. If you forget what 0 means, it gets a little bit more complicated. X-intercept. So this time they're not parabolas, they're not quadratics. Okay, these are linear equations that they've graphed, and the graphs greatest, but we can still look at them. So -4. So we're looking at our x-axis. Does the line cross our x-axis at -4? Well, it'd probably be better to count because I cannot read those numbers. 1, 2, 3. That appears to be it, right? But let's check the others. I think it's A, but let's check. So let's look at B. Again, look at your x-axis. Here's your x-axis. Where does your line cross it? It crosses your x-axis right here. What is that? That is 1, 2, 3, 4, 5, 6. Okay, so that would be 6, positive 6. Okay, that's not what we're looking for. It said -4. So again, if you know what 0 means, this is an easy question. If you don't know what 0 means, this gets way more complicated. So again, x-axis, where does the line cross it? Right here. So that would be -1, 2, 3, 4, 5. Okay, that is not what we're looking for. And last but not least, because you always should check, even you don't one and done it, always check. Here's my x-axis. Where does my line cross? Right about there. So that would be 1, 2, 3, 4, 5, maybe 5.5, give or take. Okay, definitely not what we're looking for. Okay, so yes, A was what we were looking for. All right, take a quick break, come back, watch the second video to see 9 through 13, and let us know if you have any questions.